Before we begin, I wanted to provide a bit of context. This is not a mine detonation. This footage shows HMAS Torrens being sunk by a torpedo fired by the Collins-class submarine HMAS Farncomb back in June 1999. However, the physics you're about to see are the same as those produced by modern sea mines, particularly ground mines or mines detonating beneath a ship in the water column. Interestingly, it's not the explosion itself that does the most damage, it's what happens next. I'll run the clip again and step through it. Phase 1, shockwave. This is the initial detonation. It produces a pressure wave that travels outward very rapidly through the water. Because water doesn't compress easily, that energy is transferred straight into the hull, and that's where the initial damage comes from. Phase 2, the gas bubble. This is the critical part. The explosion forms a gas bubble beneath the ship, and it expands rapidly. As it expands, it lifts the hull out of the water, right under the keel. And ships are not designed to be lifted from that position. Now, if we go back to the footage, right here, this is the gas bubble expanding and lifting the hull. Phase 3, collapse and bubble pulse. The bubble then collapses. What looks like a second explosion isn't. It's the same event, the bubble collapsing and reforming. When it collapses, it creates a void beneath the hull. The bow and stern now take the weight of the ship, and that places enormous stress on the hull. In many cases, that's what breaks the ship's spine, leading to structural failure. The gas bubble can oscillate several times, expanding and collapsing, each cycle adding further stress to the structure of the ship's hull. In some cases, a vertical water jet can form during the collapse, adding to the damage. So while this is a torpedo event, the same physics are used by mines. And that's why sea mines remain one of the most effective ways to disable or destroy a ship. Happy for comments below.